Stop whatever you're doing. Because just days ago, astronomers spotted something that shouldn't exist. Another Atlas comet. And this one is gold. Officially named C2025K1 Atlas. This mysterious new arrival has just survived a deadly, close pass by the Sun. And instead of disintegrating, it came out shining like molten metal. Scientists are calling it the golden twin of the interstellar 3I Atlas. And what it's doing right now is rewriting everything we thought we knew about comets, chemistry, and cosmic coincidence. 2 Atlas comets, 1 interstellar, and 1 born in our own system, both breaking the rules of nature at the same time, and both eerily quiet, showing no tail, no gas, and no reason they should still exist. What are the odds of that? Stick around, because the deeper you go into this mystery, the stranger it gets. And before this video ends, you'll see why many believe this golden twin may not be a coincidence, but a signal. In May 2025, while most of the world slept under familiar skies, the Asteroid Terrestrial Impact Last Alert System, known simply as ATLAS, quietly flagged a new moving point of light. The network, built to detect cosmic threats before they strike Earth, wasn't looking for beauty or mystery. Its purpose was defense, not discovery. Yet when the data rolled in, something about this faint streak didn't behave like debris or the ordinary fragments that flicker through the system's nightly scans. What began as a routine entry labeled C2025K1 Atlas soon drew the attention of every major observatory on Earth. The readings showed a large, stable core, massive, symmetrical, and oddly inert. In a sky crowded with dying rocks and icy wanderers, this one stood still, too calm for comfort. Astronomers assumed it was just another frozen relic on a slow inward fall, destined to evaporate as it neared the Sun. Nothing about its early data hinted at what was coming. As summer deepened, it crept closer to the inner solar system, glowing faintly against the constellations of Leo and Virgo. Then on October 8, 2025, it reached perihelion, its closest approach to the Sun, plunging into a corridor of radiation so intense it has destroyed every fragile body before it. Telescopes across Europe, Hawaii, and Chile prepared to watch it die. At those distances, the solar flux should have vaporized its outer layers in minutes, peeling away gas and dust until the nucleus fractured into nothing. But what they saw instead left even veteran observers in stunned silence. The comet did not explode nor even flinch. When it re-emerged from behind the Sun's glare, the live images showed something almost poetic, a perfectly intact core, gleaming like a piece of polished metal adrift in firelight. "It should have boiled," one NASA researcher muttered. "It should have burned." An ESA analyst compared it to a silent ember floating through gold-lit plasma. The comet had defied the physics of death and come out shining. Within hours, chat rooms lit up with disbelief. Astronomers rechecked their instruments, thinking the golden hue must be an optical illusion caused by solar scattering. It wasn't. The light curve confirmed a stable, metallic sheen across multiple wavelengths, something no natural comet had ever displayed before. C2025K1 Atlas had done the impossible. It had survived the Sun's wrath unscathed. The scientific world scrambled to explain it, but the symbolism was impossible to ignore. The same system that once warned Earth of danger had now revealed something transcendent, a celestial object that refused to die. They thought the Sun would burn it away. Instead, it painted it gold. When the first post-perihelion images from the Virtual Telescope project came through, astronomers expected chaos, shattered ice, vapor jets, and a ragged halo of dust trailing into darkness. Instead, they saw perfection. The new photographs revealed C2025K1 Atlas shining with an otherworldly metallic amber glow, as if the comet had been dipped in molten gold and left to cool in the silence of space. Observers from the European Southern Observatory, peering through adaptive optics, confirmed the hue was not a camera artifact. Across multiple spectra, the object reflected light like polished metal, its core smooth, symmetrical, and eerily stable. It wasn't radiating the faint bluish-green light of cyanide and diatomic carbon that define ordinary comets. Instead, Its spectrum was saturated in warm gold and burnt bronze tones, colors that no known natural molecule should produce at such low temperatures. Under normal conditions, comets display those ghostly blues and greens because sunlight excites carbon-based gases that sublimate from their icy surfaces. But this one was different. The emission lines of carbon were nearly gone, replaced by traces of metallic silicates and nickel compounds, substances more common in meteorites, spacecraft plating, or high-temperature alloys than in frozen cosmic ice. It was, in the words of one ESA analyst, too clean. A comet should be messy, a chaotic cocktail of water, methane, and dust. But C2025 K1 gleamed with the purity of something refined. Its surface spectrum matched no known natural formation, yet bore uncanny resemblance to the reflectivity curves of industrial alloys used in spacecraft shielding. The mystery deepened with every passing hour. How could an icy wanderer endure the inferno of solar radiation and emerge not blackened, but golden? Some theorized that the immense heat had melted and recrystallized its surface, creating a mirror-like crust of fused silicates. Others whispered that it looked less like geological metamorphosis and more like manufactured resilience, as if the material had been designed to survive exactly such conditions. Even conservative voices at NASA admitted, off the record, that no existing model fit what they were seeing. It should have been boiling, shedding millions of tons of ice and vaporizing into the sun's glare. Instead, it was gleaming like polished bronze under cosmic fire, silent and immaculate. The sight stirred both awe and unease, a sense that the object wasn't reacting to the sun, but performing under it. In the words of Harvard's A.V. Loeb, "When nature shows precision, look for purpose." Before the world even had time to marvel at the golden survivor, another shadow crept into the conversation, 3I Atlas, the interstellar visitor, that had already shattered every expectation earlier that year. Astronomers still remember the headlines: a comet-like body racing through the solar system at 130,000 miles per hour, venting pure nickel vapor instead of dust or ice, and glowing bluer than the sun itself during its own perihelion passage. At that time, scientists called it an anomaly, a rogue fragment from another star system, obeying no known laws. It accelerated where gravity should have slowed it, ejected elements found in industrial alloys, and produced light curves no model could reproduce. For months, telescopes around the world watched it vanish into the dark beyond Mars, carrying with it unanswered questions and a lingering sense that something intelligent might have touched its path. And now, just months later, a new atlas appears, this time from within our own solar system, bearing all the same symptoms of the impossible. Both defy disintegration in the face of solar heat. Both display spectral signatures that have no place in the natural chemistry of comets. Both move in unnatural silence, lacking the chaotic jets, tails, or vapor signatures that define normal celestial wanderers. One shines gold, the other blue, as if performing opposite sides of the same cosmic experiment. Their discoveries, separated by only a year, both tied to the same sky survey project, seem almost intentional. Two puzzle pieces placed at opposite ends of space, each reflecting the other's defiance of physics. Statistically, it's absurd. Two separate bodies, discovered years apart, each rewriting the rules of motion, light, and material composition, and both carrying the same name, Atlas. What are the odds? To some, it feels like cosmic choreography, an interstellar echo scripted by forces we can't yet perceive. It's soundstaged by the universe itself. And as scientists stare into the golden reflection of C2025 K1, they can't shake the question that now haunts every observatory's night watch. If 3I Atlas was the messenger, could this new one be the reply? At its closest pass to the Sun, C2025 K1 Atlas ventured into a region of space few comets ever survive. Its perihelion distance, just 0.33 astronomical units, placed it inside the furnace where solar radiation pounds even the toughest icy bodies into vapor and dust. Astronomers watched with a mix of anticipation and dread as it dove into that blinding halo, expecting a brilliant death. The calculations were merciless. At that range, the comet's surface should have endured temperatures exceeding 1,000 degrees C, enough to melt stone, vaporize water, and tear volatile gases from its core in explosive bursts. By every model, it should have boiled away, shedding billions of tons of matter into a spectacular tail visible from Earth. The data teams at ESA and NASA prepared for the telltale surge in brightness, the comet's last flare before fragmentation. But that surge never came. When the probes and telescopes turned their eyes toward the sun's edge, the feed went quiet. No plume, no dust jet, no radiant arc of debris marking a dying comet's passage. Instruments that should have registered violent outgassing showed flat, calm readings. The images that followed, when the glare finally faded, were almost unsettling, a smooth, luminous object drifting serenely through the heat like a stone through fire. Even high-sensitivity infrared spectrometers designed to catch faint traces of vapor detected almost nothing. The comet's albedo remained high, its structure intact, and its surface strangely reflective, like metal brushed clean by sunlight. For comparison, astronomers pointed to C 2012 F6 Lemon, a normal comet that once passed at a safer distance, yet sprouted a brilliant tail stretching millions of kilometers into space. Lemon behaved like a comet should: gas bursting outward, ice evaporating into plasma, dust streaming behind like a banner of smoke. But Atlas was different. It left no trace, no trail, no evidence of struggle. It was as if it had rehearsed the motion, executed the maneuver, and emerged unchanged. One observer called it a ghost comet, there but untouchable, and so it glided out of the solar inferno, its surface now shining with that impossible golden hue. Whatever forces governed its behavior had carried it through conditions no natural body should endure. It brushed the edge of the inferno and came out glowing, not wounded, but transformed. In the weeks that followed, scientists scrambled to explain how C 2025 K1 Atlas could emerge from the sun's furnace not destroyed, but reborn in gold. One camp proposed the thermal conversion hypothesis, that the surface melted under the sun's heat and then re-solidified into a glassy, metallic crust capable of reflecting sunlight like bronze. But even that elegant idea failed to justify its stability or the precision of its sheen. Others dared to whisper a more unsettling notion, the non-natural hypothesis, suggesting that the object's surface might possess a thin reflective film or some kind of plasma resonance layer, the kind of engineered coating used in spacecraft to manage temperature extremes. Harvard's Avi Loeb called it a riddle written in metal, while a JPL analyst admitted, "We have data without a cause and physics doesn't like that." Amateur astronomers echoed the disbelief. No tail, no outgassing, no debris, just a perfect gleaming object defying entropy itself. Across disciplines, the same uneasy conclusion began to echo. Either we just witnessed new physics, or we've stumbled upon craftsmanship on a cosmic scale. By early November 2025, the mystery deepened into something almost poetic. Both Atlas comets, the interstellar 3I and the solar-born C 2025 K1, were active in the same year, each defying physics in its own way. One blazed blue beyond the sun, the other shimmered gold within it. For a brief window, their orbital planes aligned across the constellations of Virgo and Leo, as if they were facing one another across the gulf of space. The geometry was too exact, too cinematic to ignore. It felt scripted, two anomalies staring at each other through the solar wind. The rhythm was hypnotic, one from beyond the stars, one born within, one turning blue, one turning gold. Two ends of a cosmic conversation. Was it coincidence, or was the sun itself a trigger, awakening something embedded deep in their design? Every pattern, every alignment, every improbable echo whispered of purpose. And as both continued their silent trajectories, one truth settled uneasily among observers. Maybe we're not just watching this dance. Maybe we're its audience. The clock is ticking toward December 19, 2025, a date already marked in red across observatories worldwide. That's when 3I Atlas will make its closest approach to Earth, while the golden C 2025 K1 remains fully visible in our night sky. For the first time, both anomalies will be observed simultaneously by every major telescope, the James Webb Space Telescope, Hubble, VLT, and an army of amateur astronomers pointing their lenses skyward. Forums are buzzing with anticipation, predictions and fear. Type yes in the comments if you'll be watching the sky that night. The stakes couldn't be higher. If the comets show no gas emissions, standard theories collapse. But if they emit radio pulses or structured frequencies, humanity could be staring at the first, undeniable interstellar signal in history. The countdown has begun. 40 days left until Earth stands between two golden enigmas. 40 days left to discover whether the universe just repeated itself or replied. Now, as weeks slip by and December approaches, C-2025 K1 Atlas drifts quietly across the dark, its golden glow softening, its reflections growing faint, but never gone. Every major observatory still tracks it line by line, pixel by pixel, unwilling to blink. The data streams in endless silence. No tail, no gas, no flicker of activity. Just a perfect, golden ember gliding through the void as if waiting. Somewhere beyond, 3i Atlas does the same, blue and distant, vanishing into the cold. Two objects, separated by billions of miles, both motionless, both mute, as if connected by a secret thread of purpose neither chaos nor chance can explain. Astronomers whisper of coincidence, philosophers call it symmetry. Yet, under the hum of servers and the hush of midnight observatories, the same thought lingers. It's not the light we fear anymore, it's the silence. Because silence means it's still deciding whether to speak. And, as humanity watches, breath held and telescopes fixed, we can't help but wonder if these two wandering enigmas are not just comets, but chapters in a cosmic story finally unfolding. Maybe, for the first time, the sky isn't just showing us its beauty, it's testing whether we're ready to understand it. If these comets are part of something greater, we may soon learn that we were never just observers, we were the observed. Subscribe, keep watching, and remember, every night sky hides a story waiting to answer back.